This is application. I'm continuing with applications on chapter 7, and this is part 2. Okay, so if you follow my labeling, that's actually 7J, and this is under applications but part 2. Okay, so in part 1 we went through 2 types of word problems, and this is type 3. Type 3 is work problems, so problems involving work. Let's get the problems from your textbook so you understand what we are talking about. And let's use as example 1, number 18 on page 348. So the story goes that there's two persons, there's Chanel and there's Lisa, doing a particular job. So Chanel alone takes a certain number of, in this case, days, and so does Lisa alone, but together you are told they take a certain time. So let's see, Chanel and Lisa can finish a job in 12 days, so number of days that they take together is 12. Chanel alone can do the job in 20 days, so with Chanel working, that's 20 days that she takes. And the question is asking you, how many days will Lisa take to finish the job? So let's call that X. So the way you have to think is, if Chanel alone can do the job in 20 days, think in terms of fraction of work done. So what's the fraction of work done in 1 day? So if you can do the job in 20 days, so equivalently we can divide the job into 20 parts, and every day you do 1 portion. So in that sense, fraction of work done in 1 day is 1 out of 20. So similarly, if together they take 12 days to do the job, equivalently the work done in 1 day will be 1 out of 12. Okay, and Lisa's contribution will be 1 out of X in the same format. And these are their individual contributions. So the individual contribution from Chanel and Lisa has to exactly equal their combined contribution. So that's your setup. This is Chanel alone, that's 1 out of 20. Lisa alone, that's 1 out of X. And their combined efforts is 1 out of 12. So solving this one requires you to determine what's the LCD. And in this case, the LCD is 60. Okay, and between 20 and 12 is 60, and 60x. So what we'll do is we'll multiply 60x to each fraction on both sides. 20 into 60 will be 3 times by 3x. X into 60x, so that's going to be 60. And 12 into 60, that's 5, so it's 5x. Okay, so solving this, I'm subtracting 3x on both sides. So 60 is equals to 2x. And if you divide by 2, tells you x is 30. So in answer to the question, Lisa alone will take 30 days. Okay, so Lisa alone will take 30 days to complete the job. Okay, as a second example, I thought it would be interesting to look at number 23. This is found on page 348 of your textbook. The story goes that Christy can clean the house in 5 hours, and her father can clean the house in 4. So there's a few people involved here. There's Christy, and number of hours that she can do it alone. So is Christy alone is going to take 5 hours. Dad alone, okay, the father alone is going to take 4. But what happens is Christy's younger brother, Tom, okay, so Tom, what he does is he messes up the room. So he's not helping to clean the room, but he messes it up, and he can do it in 10. So what happens is Christy and the father is going to clean the house, and the brother's going to mess it up on the side. Okay, so as a result, the question is, how long would this take? if they do all this at the same time. So Christy and father cleaning the house and Tom messing it up. Okay, so number of hours they take individually, that's 5, 4, and 10. Together, that's what we're trying to find. Okay, we're trying to find how long will they take. So in this case, let's do fraction of work done. Okay, and it's in 1 hour. So Christy can do 5 hours of cleaning, so that means her contribution is 1/5. Dad alone is going to be 1/4, and Tom alone is going to be 1/10, and together is going to be 1 out of X. The only difference is Christy is contributing to the job, so it's positive 1/5. Dad alone is contributing to the job, so it's plus 1/4. But little Tom is messing up the room, so that's why in that sense it's a minus 1/10. So what he does is he undoes the work, okay? And as a result, it's all going to be 1 over X. So let's try solving this. The LCD in this case is 20X, so multiply each one by 20X. And when you do that, 5 goes into 20 4 times, so it's 4X. 4 into 25 times, so it's 5X. But little Tom, 10 into 20 is 2, so it's minus 2X. And the x's cancel, leaving me with 20. So 9X minus 2X. So because of Tom messing things up, instead of 9X, it's now 9 minus 2, which is 7X. And so the result turned out to be 20 over 7, which is 2 and 6/7 of an hour. Okay, so with all of them happening at the same time, it's going to take 2 and 6/7 of an hour, which is 6. It's about 30. What is it? 60. Yeah. So let me see. What is that in terms of minutes? So if you're interested to convert this to hours and minutes, you're thinking in terms of like 2 hours and 6/7 of an hour, which is really 60 minutes. So this is coming up to about 2 hours and let's say about 50, it's about 51.4 minutes, thereabout. Okay, just to give you a feel. But leaving the answer is 2 and 6/7 is good enough. So how do we answer the question? We're talking about how long it takes them to clean the house, all happening at the same time. So it will take 2 and 6/7 hours to clean the house together. To clean the house together. Okay, and that's it. So to get you to practice, you should be working on some of the problems that's in your book. This is all found on page 348. Try 19, 21, and 25. The answers are in the back. Okay, let's look at the last type of word problems that's discussed in the book in this section. And this last type is called variation. So under variation, there's a few types. You might want to refer to that table that's in your The table is found on page 345. 345. Okay, so turn to 345, and here you are told that if y varies directly, for example, when y varies directly as x, what happens is, as an equation, y is equals to kx, okay, and k being the constant of variation. Now, what happens is this. What exactly does it mean by y varies directly? Okay, so what this means is if y increases, then x increases. If y decreases, then x decreases. So each one is related to the other directly. So we used to call this direct proportion, and this is just another way of saying it. So y varies directly as x. Okay, the other one that you need to consider is what happens if we say y varies inversely as x as an equation. That's when you say y equals k over x. And inversely just means if y increases, then x decreases, just as if y decreases, then x has to increase. So we used to call this inverse proportion, and varies inversely is just another way of saying this. Okay, so this is the same as what you learned in the earlier math, where we call it direct proportion, whereas this is where we call it inverse proportion. Okay, so this is just a different way of saying the same thing that you've learned before. There's one other thing that is a little bit different from what you have seen before, is where we combine the two, as in it varies against two things. And so if we say that, let's not use y, I'm going to follow your book, z varies jointly. Okay, so this is something new. Z varies jointly as x and y. So all this means is that z is dependent on two things. Okay, is it dependent on x and is dependent on y. So as an equation is z equals kxy. Okay, so let's look at some examples to see how this is being used. As an example 1, let's refer to your book on page 349, and I'm looking at number 30. So in this question it says that A varies directly as B. Okay, so because you're told A varies directly as B, what you're trying to say is that A is equals to K times of B. So your job is really to find the K, and that's when you have to read on that says when A equals 8, A equals 8 when B equals 20. So that's when you will substitute B as 20. So 8 is equal to K times 20. And if you divide by 20 on both sides, tells you that K is equals to, let's reduce that, 8 over 20, if I divide by 4, is 2 over 5. So as an equation, A is equals to 2 over 5 B. So the next part of the question is saying, can you find B when A is 54? Okay, so all you have to do is put it into the equation. A is equals to 2 over 5B, and you're told A is 54. So 54 is 2/5 of B. So now you have to solve. And to solve for B, you're going to have to use the reciprocal of the coefficient 2/5. So I'm going to multiply both sides by 5 over 2. So that the 5's cancel and the 2's cancel. And I'm allowed to cross over B because this is multiplication. And multiplication is commutative. Okay, so I can switch the order. And so B is left alone, which is what I want. And 2 into 57 is 27. And 27 times 5 is 135. So that's the answer. So it says that B is 135 when A is 54. So true enough, you can see as A increased from 8, so when A was 8, so this was the story, when A was 8, B was 20, right? And then when A is 54, you found B to be 135. So you notice that A increased, B increases too. Okay, so this is what you call direct proportion. So let's look at another example, something with joint. Let's try that. Let's call this example 2. Let's do number 40 and page 349. So this time you're told that Z varies jointly as X and Y. So once you see this, straight away you write the equation. z equals kxy, as in it depends on two variables. And that's when you have to read on, because you need to be given information for you to figure out what k is. And you're told that z is 15 when x is 5 and y is 3. So let's substitute that. Z is 15, k times x is 5 and y is 3. So 15 is equals to 15k. So if you divide by 15 on both sides, it tells you k is 1. So when k is 1, that's when you put back into the equation. So z equals 1 times xy. So that becomes a formula, okay, for that problem. And now the question is saying, can you find z when x is 25 and y is 4? So let's substitute that. So what you have now is z equals to 1 times 25 times 4, because x is 25 and y is 4. Okay, so that tells you that z is 100. Okay, so this is what we mean by variation. So usually you're told what it varies, and what you really need to look for is the constant of variation, and from there you should be able to solve all the problems. So let's see, let's get you to try some. This is found on page 349. Let's get you to work on numbers 31, 33, 35, and 39. So if you have any questions, feel free to bring it up in class. All right, have fun.